Starting at the Great Lakes, the St. Lawrence River drains over a quarter of all the fresh water on the planet. So where does all that water go?
Freshwater ecosystems and oceans are linked. All freshwater lakes and rivers eventually drain into an ocean somewhere. St. Lawrence River drains all of the Great Lakes, and that water makes its way down into the Gulf of the St. Lawrence near Prince Edward Island.
The mouth of the river, known as the Gulf of St. Lawrence, is the world's largest estuary, where fresh water from a river meets saltwater from the ocean.
But once you get down to Quebec City, you start to get into a mixing zone. Because saltwater is heavier than freshwater, you get these two wedges kind of one on top of the other. So you get some really interesting things going on, and you can detect those effects quite far from the Gulf of the St. Lawrence River.
This complex ecosystem sustains life for millions of people, animals, and plants, which means monitoring the quality of water is critical. But we aren't just looking at whether the water is fresh or salty.
Water quality is so important, no matter if you're in the ocean or freshwater systems. Things that are really important for organisms that live in the water are things like temperature, and of course fish need oxygen to breathe. Other things like the clarity of the water, that's really important for some species that hunt. So large predatory fish, they would want really clear water to be able to see their prey.
With a river as big as the St. Lawrence, studying the actual water is no easy task.
River water flows by and it's here today, gone tomorrow. It's much more dynamic than water that stays relatively still.
So, how do you keep track of so much water that's constantly moving? If you really want to know what's happening in the St. Lawrence, you've got to get wet.
There's the rock.
The River Institute has placed more than 20 temperature loggers in this area of the St. Lawrence. Without the GPS coordinates, you'd have a hard time finding them, though. They're disguised as rocks. Each one has been recording the river's temperature every 15 minutes for the past year. So this uses light, right, to transmit the data?
Yeah, it uses infrared light, and it pulses through these two little dots, and then we connect the base station here to it, and that's how it transfers the data to our laptop. As of right now, this is what the temperature logger has collected.
And you can see the lowest temperatures here, eh? So this is November, and it really gets super cold end of November, January.
And when it's super flat like that, that means the logger is under ice. We're noticing a huge difference between the loggers that are out in the open water and the ones that are in these little inlets. We've noticed the biggest difference was 10 degrees, which is really interesting.
A lot of the organisms in the near shore area and the tributaries, that habitat is especially important for fish.
Fish spawning and fish growth.
Just like you and I, animals that live in the water have a preferred temperature, especially fish. And some fish can be more sensitive than others to changes in that temperature.
They can't escape that. They can't move to a different habitat, move indoors like we would, in humans. We can escape the weather a little bit. Whatever the water temperature is, that's what they're stuck with.
That's a pretty direct and obvious impact of climate change, but there are more subtle potential impacts as well. If you change temperatures, you may evaporate more water, you may change water volumes. If you have less water, but the same amount of pollution, that pollution is less diluted, it's more concentrated, and it could possibly have greater effects on species that are exposed to those contaminants. It's not just simply that it's too hot for them to live.
Okay, so monitoring water quality can help us protect fish species. But did you know that some fish can also help us monitor the quality of water?
So this is a yellow perch, and you can tell because of a couple of things. One of them is that pattern on the side, so those vertical dark green bars. We're looking for a forked tail, and then 2 dorsal fins.
Perch is considered a local delicacy in this region. For scientists, they're also an important indicator species. The perch population can tell us about the environment in which they live.
We got used to catching unnaturally large quantities of perch and large individual perch because there were so many excess nutrients in the water.
So, nutrients feed plants, which in turn feed invertebrates. Perch like to eat both. So, perch thrive when there's lots of nutrients, like phosphorus, which was once used in the dish and laundry soap that often gets flushed out into lakes and rivers. But if nutrient levels get too high, it can overwhelm the aquatic ecosystem.
People have attributed declining perch populations to deliberate efforts to reduce phosphorus coming out of municipal wastewater plants and other industrial sectors.
So, less perch suggests lower levels of nutrients, and that suggests the quality of water here can in fact be improving. Improvements in the quality of water is a step in the right direction, but it's only one step in a long journey.
Things are changing very quickly. I worry that people don't appreciate what's happening. What people think of as normal now is actually, in most cases, vastly different than it was even 100, 200 years ago on the river.
It's a journey that must continue for all who depend on the St. Lawrence, now and into the future.
We're establishing what are called baseline data sets. So that's just a really in-depth look at the current conditions of the river right now. This is what it's like now, and in 10, 20, 30 years, it will have a great data set to compare to, and then that can be used to track change.